All right, this video is going to have two concepts. One is simplifying square roots, and the other is solving equations using square roots. So if we start off by looking at some problems where we're simplifying square roots, our goal is to come up with factors of whatever's underneath our square root where one of them is something that we know the square root of. We call numbers like that perfect squares. And so we're looking for perfect square factors that we can split up the square root into. So I'm going to write some perfect squares, like 1 squared is 1, although that's not something that is helpful for this because everything is divisible by 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I'll keep going just a little farther. I feel like that's probably plenty far enough because hopefully these numbers are fairly small. So if a number's not even as high as 64, 64 is not going to be a factor. But this gives us a list of the things we're looking for. So for instance, for 18, the things that multiply together to get 18 are 2 and 9, 1 and 18, of course, and 3 and 6. Now, what we want to pick out of these, sometimes there's more than one thing we can pick, and sometimes there's only one option. Like there's only one option here that is helpful. The 2 and the 9 are helpful because if I split this up into the square root of 2 times the square root of 9, then I can take the square root of 9. I know that the square root of 9 is 3, so I'm going to change that to a 3. The square root of 2 I don't know, and I'm going to leave as the square root of 2 because 2 is a prime number. So the only thing we could do with it is we could find the decimal on the calculator. But the whole point of this is we want to simplify it into something that we could use in a problem. Like if we needed to do something else with this number, we could use it and it would be in its simplest form. So 3 square roots of 2 is square root of 18 simplified. So let's look at some others and see if we can get the hang of it. There's actually another way to do this as well. And we'll look at that, I think, on at least one of these so you can see the other way. Actually, let's do it on 12 because maybe it's obvious what we would pick here, but let's pretend it's not obvious. The other way to do it is to make a factor tree. So we could say 2 and 6 is 2 and 3. And so basically when we make a factor tree, what we're trying to do is look at these numbers we have and pair them up if possible. So if I pair up these 2's, together they make 4, which I can take the square root of. This 3 doesn't have anything to pair up with, so it's going to have to stay just 3. So we can figure out that the square root of 4 is 2, and then the square root of 3 is just going to stay square root of 3. Now these numbers that are kind of small, it might seem like a lot of work to do a factor tree for. I save factor tree usage for times where I have a number that I just can't figure out what goes into it that's a perfect square. But the idea is a pair of numbers is going to make you put one number on the outside and then any numbers left over are going to go on the inside. So we'll look at 48, the number 48, and we'll try it both ways. So if I do a factor tree, maybe I can come up with 6 times 8 from my multiplication tables. So that's 2 and 3, 2 and 4, and then 4 is going to go to 2 and 2. So what I'm looking for is pairs of numbers. There's a pair of 2's. They don't have to be right next to each other, but there's a pair of 2's. Here's a pair of 2's. Each of those is going to have like one representative from the pair that goes outside because each of these is representing a 4. 2 times 2 is 4. And so we'd square root them both and get 2's on the outside. Then on the inside, we have a 3 left over. So this is 4 square roots of 3. If you're doing it the other way, probably the easiest factor to think of that will work for this is 4 and 12. That 4 has a square root. 12, we don't have an actual square root for, so we can go to a next step where it's 2 square roots of 12. But square root of 12 can still be simplified, right? We said over here that square root of 12 is 2 square roots of 3. So if we don't think of the biggest perfect square factor the first time, that's okay. We just have to be willing to keep going. So square root of 12 can split up into 4 and 3. And so that, again, is how we end up with 2 2's on the outside. And together we put 4 square roots of 3. So that's the two different methods. You just need to figure out which way seems easier for you. You don't have to do both methods. But if you're just going with the method where you don't use a factor tree, then you're going to want to make sure that you can come up with perfect square factors pretty easily. You have to be willing to divide 4 or 9 or 16 or 25 into things to see if they're perfect square factors. So 27, we can make a factor tree, or we can say, oh, this is 3 times 9, and then split it up into square root of 9 and square root of 3. That isn't, you don't really have to write both steps. I don't know why I keep doing that. Our answer should be 3 square roots of 3, either because we said, oh, it splits up into 9 and 3, and I can take the square root of 9, or looking at this and saying there's a pair of 3s, so we write a 3 on the outside, we have a 3 left over, so it goes on the inside. So our answer is 3 square roots of 3. Square root of 8. So this is like having 2 and 4. Also, if you start to make a factor tree and you realize that the very first thing you picked works, then you can square root the 4 and get 2, and don't square root the 2, leave it underneath. And that's also an option, that if you start the factor tree and you notice that you have a perfect square, then that's fine. Square root of 50 has a 25 in it, 25 times 2. And so the square root of 25 is 5, and the square root of 2, we're just going to leave square root of 2. Now on these next examples, we're going to have some other numbers involved. So either numbers in front, or more than one square root, or fractions, things like that. So what we're going to do is we're going to see if we can simplify our square root here. And if we can, then we'll bring the 4 in and see what we need to do with that. So for instance, the square root of 100 is just 10. And so it's not going to be under the square root anymore. It's just going to be at 10. And there's really multiplication in between here. We don't write it. We just write them right next to each other. But what we're doing is multiplying. So we need to multiply 4 times 10, which gives us 40. That would be our answer. On 18, we've got the square root of 20 that we need to simplify. And again, the 4 is just going to hang out until we're ready for it. So 20 can split up into 4 and 5. We can take the square root of 4 and get 2. But we can't take the square root of 5, so it's going to stay. And so now that this is a 2 on the outside, the 4 and the 2 can get together and become 8. So in case you haven't already picked up on this, you're allowed to multiply things that are outside together, like this 4 and this 2. As soon as we got the 2 out of the square root of 4, we multiply them together. We can't do like 2 times 5 or 4 times 5. Can't do anything with that 5 unless there's another square root, like there is on 19. We're allowed to do 12 times 3 and write this as square root of 36. It's helpful to do that to check to see if it works out nicely, to look at the square root of 36. For instance, the other way to do this is to simplify the square root of 12 into 2 square roots of 3, and then multiply our square roots together, and then check to see if we can simplify. But if we just go ahead and multiply first, the square root of 36 works out great because it's just 6. Either approach is fine, just it's helpful to check to see if multiplying them together first helps. And actually, I would say, just the way this worksheet is set up, all of them are probably easier to do if you multiply them together, because our numbers don't get too big, and that way we'll only have to simplify once instead of having to simplify maybe twice. On 20, we'd start with -4. Let's multiply the 10 and the 2 together. We can't do anything else because 10 doesn't simplify and 2 doesn't simplify. But when we get them together as square root of 20, that does simplify. In fact, we just did this up here, right? That this changes to square root of 4 and square root of 5, and the -4 is still in front. So -4 times 2 times the square root of 5 is -8 square root of 5. This final multiplication one, 6 and 10, can't do anything with those by themselves. Another way to do this, though, is you could go ahead and, it's kind of like making a factor tree. We could go ahead and just write out what all of them are as factors, like 6 is 2 and 3, 10 is 2 and 5. If they're small numbers like this, that's pretty easy to do. And then, again, we can look for our pairs. There's a pair of 2's, so we should have a 2 on the outside because we're saying square root of 4, which is 2. The 3 and the 5, though, don't have anything to pair up with, so we should end up with a 15 on the inside. That's the same as the square root of 60. So 2 square roots of 15. Now when we have fractions, there's a couple of different things. Like we can still basically, what was I going to say? We can do similar things, but now instead of like here we multiplied by a 4 or a negative 4, we're going to have to check to see if we can basically simplify top and bottom like a normal fraction, like how if you get 10 halves or something like that, you can simplify that to be 5. We're going to look out for things like that we can do since they're fractions. So there are multiple ways to do this, and I'll go ahead and show you both. We can just say, well, the square root of 100 I know is 10, and then we can simplify the square root of 12, which I think we did. Well, we did it right here. Square root of 12 is the same thing as the square root of 4 times the square root of 3, and the square root of 4 is 2, so that's 2 square roots of 3. The 2 and the 10 can simplify because they're both divisible by 2, and so that leaves us with the square root of 3 over 5. There's another way we could have done this. You are allowed to take the 12 and the 100 and simplify them together first because they're both under square roots, even though they're not under the same one. We can simplify 12 over 100, which they're both divisible by 4, so we'd get 3 and 25. And then we can say, okay, what's the square root of those? And so we can't simplify the top, but we can simplify the bottom. So we'd get the same thing that way. There are times where one of those ways might be easier than the other. So it's nice to be able to know that you can do it both of those ways. So if one way isn't working out very easily, you can try the other one. Let's look at a couple more examples like that. All right, both of these examples we can do either way that we just talked about on the other problem. You will notice, if you haven't already, that we end up reusing numbers pretty easily. Like we've already figured out somewhere else on the page what the square root of 8 is when we simplify it. And so if you're doing a whole bunch, it might seem repetitive, but that's actually helpful because then you'll have seen it before, so it'll be easier to do it again. So what I'm saying is that by the time we get to a quiz or a test, you may have already done all of the numbers that we've simplified before, but that's helpful. That means that you're more likely to do it correctly. So one way to do this is to say the square root of 8 simplifies to be 2 square roots of 2 because we split it up into 4 and 2. And we can take the square root of 4, but we'll leave the square root of 2. The square root of 2 on bottom would stay for now. You're allowed to cancel these out. If they're both the same number underneath the square root, they can go away, just like if that was a 2 over a 2, which means that my answer is 2. The other way to do it that might seem easier is to say, well, what is 8 divided by 2? It's 4, and then what is the square root of 4? It's 2. So again, we can get the same answer 2 different ways. And so whichever way makes more sense to you is fine. On 24, square root of 20 over square root of 16. I will go ahead and tell you the answer. Well, I'll give you a moment. So pause the video if you want a chance to work it out yourself first. And then when you unpause, I'll tell you the answer. So your answer should be the square root of 5 over 2. There's the 2 different ways to do it. One way is to say 20 over 16 simplifies by 4. So that's 5 over 4. And so we'd square root both of them and get square root of 5 over 2. The other way is to say I know that the square root of 16 is 4, and I can simplify the square root of 20 because it's the square root of 4 times the square root of 5. That gives me 2 square roots of 5, and then we can cancel a 2 off of the top and the bottom. So 2 ways to do the same problem. It doesn't matter to me which way you do it, so whichever way makes more sense to you. There's also, like on any of these problems, if it helps to like take them and just write them out as their primes. Like 20 is the square root of 2 times the square root of 2 times the square root of 5. And 16 is the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. And we can get that from a factor tree if we don't know it off the top of our head. The square root of 2's, both of those cancel, and now we have square root of 5 over square root of 4, which the square root of 4 is 2. There's lots of different ways that you can come up with to do this. Now going back to solving equations by taking square roots, when you have an equation that has an x squared but doesn't also have like a plus x anywhere, then our goal is to get the x squared by itself with the number on the other side, and then to square root both sides to find the answer. So the answer to this problem is whatever the square root of 16 is. And the problem here is that there's two answers, and it's easy to forget that there are two answers, because 4 times 4 gives us 16, but so does negative 4 times negative 4, because when I multiply them together, the negatives cancel out. So we can say that our answer here is 4 and negative 4. It's nice when it's a number like 16 that we know the square root of, but that's not always going to be the case. So here, when I square root both sides, I get that r equals whatever the square root of 8 is, which we don't know. And so we would use our tools that we have now where we can simplify square roots, and we would simplify this. The square root of 8 is the square root of 4 times the square root of 2, so that's 2 square roots of 2. I'm going to have a positive version. I didn't mean to put that comma there. I'm going to have a positive version of that answer and a negative version. So I'm going to have 2 square roots of 2 and negative 2 square roots of 2. You also can write those together. There is a plus and minus sign. That's what we call it, a plus and minus. That tells people who are looking at it that you mean positive 2 square roots of 2 and negative 2 square roots of 2. It's not saying like it's plus or minus, even though that's the way we read it, which is kind of confusing. But that symbol means that it's both positive and negative. So let's look at a few others. There's actually like 8 more of these that we can look at just to practice. So now we're adding in other things like the idea that if this was just n minus 8 equals 17, we'd start off by adding 8 on both sides. So n squared equals 25. We'd think about what the square root of 25 is. It's positive and negative 5, so we can say that n is plus or minus 5. On number 4 here, this negative in front is like a negative 1 that we can divide over. I didn't mean to mark out the x there. That means x squared equals positive 37. We want to square root both sides and get x equals. Now, the square root of 37 is a prime number, like 37 I mean, is a prime number. So that means that all we can do is put the plus and minus sign in front. This is plus and minus square root of 37. So as frustrating as it is, if it's something that's a prime number, that means that you can just leave it. You don't actually have to figure out anything else. You just have to make sure to keep the square root symbol and the plus and minus sign. So these are just some more equations where we're going to have to go ahead and solve using just our normal equation solving skills. Like here we want to add the 2 over to the other side. So x squared equals negative 9. Now here's where it gets tricky. There isn't a real answer to the square root of negative 9. And so this video is for Algebra 1 students. In Algebra 2 you would talk about what the square root of negative 9 is, but in Algebra 1 we're just not going to worry about it right now. So the answer to this is actually no solution, because there is not a number that when you multiply it times itself will give you a negative 9. So think about timesing 3 and 3 together. That gives us a positive. Negative 3 and negative 3 together. That gives us a positive. If we do 3 times negative 3, we can get negative 9. But then we haven't multiplied a number times itself because these aren't the same number. So anytime you end up with x squared equals a negative number, we should end up with no solution. So maybe that'll happen again. And in fact, if you wanted to go ahead and start pausing the video and then trying to work out problems yourself and then unpausing to see how you did, this would be a great time to do that. So on 6, we want to divide by negative 2 and get x squared equals positive 100. and then square root both sides and think about what is the square root of 100. It would be 10, so our answer is positive and negative 10. 7, we want to add 10 to both sides. And some of these numbers get kind of big, but they also should work out pretty nicely. Like we added 10 over, but then when we divide by 6, oh drats, it's the same answer a second time. That's not what I wanted to have happen. Oh well. We have 100 again, so that means that we're going to square root both sides and get positive and negative 10. Maybe this one will give us a different answer. Let's add 5. And get 200. Divide by 10. And get 20. So then when we square root both sides, there's not a square root of 20, but we can simplify the square root of 20 to be square root of 4 times square root of 5, so that means 2 square roots of 5. So our answer is positive and negative 2 square roots of 5. Just 2 more problems, and so these are all going to seem pretty similar. There's not much variation. Our answers are really where the variation happens, like 62 plus 2 is 64, then we can divide by 4. And if you need to take 64 divided by 4 out to the side and do some division like this, it shouldn't be hard. It's just that sometimes it helps us to write it this way instead of trying to do it in our head. A squared equals 16, so we're going to square root and get that a is positive and negative 4. Just a note, when we take the square root of 16 and get 4, we don't keep writing a square root symbol. So if you do, you might accidentally square root it again and get 2, and that would not be the correct answer. We only want to take the square root here once, and then it's over. If we can't take the square root, we do leave the square root in the answer. But if we're actually able to say what it is, the square root doesn't keep hanging out in the problem. Now on 10, this may look like a terrible, terrible thing for me to ask you to divide, right? Because we have to do negative 119 divided by 7. Oh no, actually it's not that bad because 7 goes into 11 once and has 4 left over. 7 goes into 49 7 times. But actually, even before we figure out negative 17, we could know what the answer to this is, because the fact that this is a negative means that we have no solution. So that is solving equations using square roots. That gives you an idea of when we could have no solution, and also how to simplify radicals. If you need more practice on simplifying radicals, like just start going through numbers. Like start at, well, it might be kind of boring if you start at 2, but start with square root of 2, then go to square root of 3. Those can't be simplified. Square root of 4 is 2. Square root of 5 can't simplify. Square root of 6, well, that's 2 times 3, but that doesn't have any pairs. Square root of 7. Square root of 8 we can do. Square root of 8 is the square root of 4 times the square root of 2, so that's 2 square roots of 2, and you could just keep going with that list. And I have a feeling if you type in something like the square root of 8 into Google, it might actually tell you the answer. If you like this video, please hit the thumbs up, and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching.